Hello everyone. Today I'm going to talk about debugging and how to debug a firmware which is on board, which doesn't have any interface so you can see what's happening. There are multiple ways that you can help yourself while debugging. First, let's talk about the problems. As I mentioned, it doesn't have any interface. You cannot see, doesn't have a graphical screen, of course, if you're not using a screen. So you don't have any feedback graphically, which you are probably used to when working on high-end languages like C#, Windows development, or Java, or anything like this. Also, there is no step-by-step debugging. You can't simply pause the execution of the software firmware and then choose to continue or not. Once you put the firmware on the board, it is running forever inside the loop, of course, and you can't see the state of variables. Of course, there are many other technologies like, for example, JTAG and so on. However, in our domain, which is a bit higher than this, you can't see the variables. However, you could see the state of registers if you're into this low-level development, but we are sticking to the Arduino and higher level. Also, another problem in this environment is that we are working in mixed environment with hardware and software. While debugging, the error can happen on both hardware and software, and that is a bit inconvenient. There are several error types. I think in software development you have syntax errors. The same is here. If you have an error in your syntax, all you have to do is compile, and the compiler will tell you what went wrong. Also, you can have runtime errors. It means if this happens, the board is not working, and the point is to avoid those any kinds of error. And there are also logical errors. Everything works fine, however your logic doesn't seem good, and the biggest source of logical errors is the developer itself. So in order to, let's say, debug logical errors, you would probably use serial port, which is the topic of today's video. And of course, you have a lot of hardware issues, hardware error, where you probably made a bad connection and so on. To check connections, you would probably use something like multimeter with connectivity checking and so on. And let's stick to the serial stream. I mean, the serial communication is way more than just debugging. Of course, it's a feature that any component uses every day. For example, computer mouse is using a kind of serial communication to communicate between mouse and a PC using USB cable, of course. But in this scenario, introduction to serial communication is going to be, for example, for a debugging case. To start a serial stream, in setup of your firmware, in setup method of your firmware, you would probably write serial begin with the baud rate. It's kind of like a speed bit rate. And to write to the stream, it's very simple. You use serial.println, and in parameter you put everything you want. And on the other side you use PuTTY or a serial monitor. I will use PuTTY because the PuTTY has PuTTY, right? It has two-way communications, while the built-in serial monitor from the Particle and Visual Studio Code is only one way. Also, this is the settings for the PuTTY. Its baud rate is the one that you actually set in a serial begin. It's 9600. Data bits, stop bits, parity, these are default settings. And let's begin. So what we're going to do now, we will start with the blink that we did in previous video, using either D5 or D7, and we will transmit the LED state to the serial stream. Okay, I still have my example from previous video. It's called Hello Tiny World. You can create a new project, which would be probably the best, so you have a separate topics. But I'm just gonna skip into this code and expand it a bit. The first thing that we want to do is to create our state, the variable for the LED state. And let's do bool state. Let's call it actually LED state equals to false. And this is also just a remark. This is also low, and this is also 0. We could use integer, we could use instead of bool and use the zeros and ones. I'm gonna use the LED state as a bool variable. It's actually a good practice to keep the memory requirements as low as possible. Obviously, the bool variable requires much less memory space than integer variable. Okay, as I mentioned before, in the setup, I will use serial.begin with the baud rate 9600. It's actually a default one. And in the loop, let's kind of print the state. Serial.println state, or like this, state. LED state. It will output zeros and ones, so you will know. I mean, you could print something. Let's do this. Serial print without print line. LED state is, and use it like this, so it will print it in one line. And now all I have to do is replace this with, instead of high, I'm gonna do LED state, and I'm gonna do the toggling at each loop, at each cycle, which means that I have to toggle the LED state. LED state equals to negative LED state. Those who know, this video is introductory, of course. I know that there is a formatted print and so on that you can make things much easier, but I'm focusing on readable aspect of the whole code. And this is it. This is very simple code. Let's put it in a single page there, and we can try the code. I'm gonna plug in the board. Of course, as I mentioned before in the last video, cloud compile. If everything is fine, you can do cloud flash. Our code has compiled, and I see the 2 bin files, and it is a very good idea to delete those bin files. Otherwise, sometimes, not always, sometimes the Visual Studio Code can mess up all the files. Although everything happens over the air, still, from my experience, remove the bin files. Okay, let's flash the code, cloud flash, and I have my putty. I don't know how is it in English. Putty, P-U-T-T-Y. It doesn't matter. Now my board is flashing. You can see this by observing the orange, the RGB LED, and you can take a look at the LED, which is on D5. It is blinking as it should be based on the code, and you have a bit problem here because you don't know the COM port. Open Device Manager, and you can see in the list of ports I have only one. It's P1 serial, it's COM3, and in order to open serial communication on this COM port, I need to write here COM3 and switch to serial, switch back to number 3 and open, and you can actually see the LED state. It says 0, 1, 0 on, and you can actually see on the board itself it actually matches. And this is it. Why is this very convenient for debugging? For example, now you can see, if you're wondering if some part of the code is not being executed, you can actually put markers like, for example, here, let's say print line. If you want to know if this is something that I do quite often, if I want to know that line 13 is being executed, 13, I just put here 13, and I know that the 13 went through the loop and it's being executed. And this is the best I can do. I mean, you can't, if you're debugging and you want to find a bug, the serial communication is very useful, because aside telling you which part of the code is being executed, of course you can output the variable value, so you can actually debug the logics itself. Anyway, I hope this was helpful, and see you next time.